Hi everyone, welcome back. Lastly, we learned about SVM, how to initialize it, and we already talked about it. And also, we compared SVM with the other ML classes which we have already learned in this video series. And today we are gonna focus to these member functions and member parameters. Can be better also we are calling them. So we are gonna focus them, but not at all. I already chose three of them, which is set kernel, set type, by the way, yeah, set type, set kernel, set C, set gamma. So these four we are gonna focus. Also, the people who are maybe directly watching this video, let's run it, what kind of example we are dealing with. In here we already have two data which I manually created in this generate circular data function, and also I added I added comparing to the previous video, just these two region visualization effect I added. So now you see which red circle region exactly is, and also you see which this blue circles regions is. So in here you can estimate any new data comes to here or comes to here, you can easily see which region it is belonging. So basically like that. So don't bother with the rest of the code, just focus these four important parameters. And we are gonna start with the kernel, which is the most important one. Kernel is set as RBF, also defaultly I think is set to the RBF. Let's see. Yeah, it's defaultly RBF. And because RBF also the most popular one, also mostly if you are using SVM of OpenCV, you are gonna be needed RBF, I believe. Otherwise maybe you can solve your issues with the other method, other classes also. RBF stands for radial basis function. Also it's written in here, a good choice in most cases, because yeah, it's working. By the way, this example I'm showing you, nonlinear data separation, is a really difficult case. So it's a challenging case to separate, so RBF is already doing it beautifully. And the other most popular one is the poly and linear, but I will not suggest you to use linear of SVM at least, because you can do linear separation. There are many simpler tools than the SVM. For example, in here, if you are using linear, let's see. Since our data is non-linear, of course it's not gonna be able to separate, but you see, right, you can achieve this with other methods also. But yeah, linear, since our example is not based on that, it's not gonna work well. The other one is poly. Poly is also, for our case, it's not gonna be working well, I believe. Also it's crashing because yeah, it's needed the kernel parameter degree. Let's see, svm dot set degree. So degree is needed, I think. So let's start with 3, and also we can read the oops, what's happening? Yeah, anyway, this is this degree is not directly, you can this is not the angle meaning, so this has somehow affecting the poly kernel algorithm. So it's not the angle, just need to remind. And here you see it looks working like this. Which kind of data it is gonna work well, I can say to you. This one, for example, remove this data. Just imagine there's a group of data in here, and in this corner, let's say in heroes. So it's gonna beautifully separate these three group of data with the help of poly. So it's working in this kind of cases, in this kind of separation cases, it's gonna work well. And but our focus is gonna be RBF. Let's continue with this one. And the other type is SVS, CSVS. This is a standard classification of the SVM, and it's mostly used this one. Actually, I didn't use the rest of, just new SVS. I give it a try before, so we can also try. But since our case is basically we chose RBF, it's not gonna make much difference. But of course, since this is new, you need to set new between 0 and 1, it says. So we need to set new to be able to see the effect of new SVS. Okay, set new, let's give it 0.5 and see how it looks like. Okay, now it's also separating, but of course you need to update this new. For example, if you give it very close to the 1, it's gonna be overfitting and it's not gonna generalize well the inside data. But if you give it very small, now it's gonna generalize well, you see. So this new SVS in some cases working well. Let's see any explanation in here. N-class classification with possible imperfect separation. So yeah, it's just also telling the new effect, the smoother the decision boundary. So the larger value, the smoother the decision boundary. But the larger value we have seen is more overfitting. So yeah, I don't know, maybe the explanation is a little bit wrong, I don't know. But now we are focusing to do CSVS, so let's switch it again. And now we already removed the new. And the C is important also. It controls how much you punish misclassified items, misclassified elements. For example, currently this is 2.5, but I think I'm wrong in here also, because it's also between 0 and 1. Let's see, and here you see this is like that. Even you give 200, I think it's gonna looks like the same. So this is a data between 0.9 between 1 and 0. So the closer to the 1 is more generalizing, it's less punishing the data in here. But if you make it 0, 0, 1, so it's gonna looks like, yeah, overfitting. You see only in the middle, very middle, we see that. But mostly, yeah, keeping according to you, if you really want it to overfit your data, you can make this value smaller. Gamma is maybe the most important one about the controlling the radius of the effect radius of each element. So in here we keep at 0, 1, but let's see, this is, I think it's also working oppositely by division. Yeah, if you make it 0.9, it's gonna really overfitting. But if you make it 0, 0, 1, so just by it's working with a different ratio. So you see with circle effect now is high. In here you see in the red circle the radius, effect radius is high. By giving this set gamma smaller, it's working opposite direction. So if you getting smaller, you can get a generalized data. If you make it little more smaller, you see, right, you can increase the effect of radius of the elements and decrease accordingly, setting this gamma value. Basically these 4 member functions are the most important one for the SVM, and mostly we focus those for this video. And in the next video maybe we can also talk about the others. Let's see, I will think about it. Thanks for watching, see you in the next videos.